In this question, you have to sketch f of x is equal to the absolute value of 3x minus 4 plus 2x. So this is a way of doing it. So this becomes y equals 3x minus 4 plus 2x. So it becomes the absolute value part that's equal to the positive of this for x values that make that positive. So the way you do that is you say 3x minus 4 is going to be greater than 0. So from there 3x would be greater than 4, and then x is greater than 4/3. And then you just have to tidy this up. So 3x plus 2x is 5x minus 4. So that's the first part of the hybrid function. That's the rule for these x values. So that's the first bit done. And to find the second bit, all you do is take the negative of all of that. So the easiest way of doing that is just to go minus 3. Let's make sure I write that 3. So minus 3x minus 4 in a bracket plus 2x. And that will happen for this part here having x values that make that negative. And then that negative in front of negative of that makes the values positive. And that's what the absolute value function does. It makes all the values of whatever's in here positive for whatever values of x you have. And you just do the opposite of what you've got here. So that's x less than 4/3. One of them has to be an or equal to. It doesn't matter which one. So I might as well make this one here. And then tidy this up, and then that's minus 3x plus 2x, which is minus x, and then minus minus plus 4. So that's, or those are the two parts of the hybrid function, this here and this one here, and just putting this is for x less than or equal to 4/3, and just underlining that so those two go together. Sorry, not this one here, this is the one I meant. That's why I need to underline them. So I'm going to use a different color. So that's the rule there for that domain, and this one here for that domain. And that's what I've got to sketch over here. So I'm going to start with this one. So 5x minus 4, linear function, gradient 5, y-intercept of minus 4. And that's cutting, say, here, and fairly steep gradient. So just something like that will do. And this is definitely minus 4, the y-intercept. And then looking at this one here, minus x plus 4, negative gradient, and cutting through 4 on the y-axis. So that's up here and doing something like that. Not as steep as that one. This one probably could have been a bit steeper. However, and I'll see if I can get that through the 4. That we'll say is 4. It could be a little bit higher if I was going to make this really accurate. And then you need to find this point of intersection here, and that you should find the x-coordinate of that is 4/3, and this value here is going to be 4, and the point where the graphs meet will always be this value that's common to both parts of the domain of the absolute value function. So to show you that, so I've nearly finished that graph. So if x equals 4/3, then this becomes, so y equals 5x minus 4, that becomes equal to 5 times 4 on 3 minus 4. This is 5 times 4 is 20 on 3, minus, and 4 is 12 on 3, and then that equals 8 on 3. So that's 8/3. Alright, so that's the y value at that point where x is 4/3. Now scale is a little bit wonky. If that's 4, that really should be about 2. But anyway, and this here, the y value corresponding to that point, that is 8/3. And subbing x equals 4 on 3 into this equation, you get y equals, so minus x is minus 4 on 3 plus 4, and that's equal to minus 4 on 3 plus and 4 is 12 on 3, and this equals 8 on 3 also. So that's the point of intersection. So I only want this part of the graph for x values greater than 4/3. So that's this graph here. Here's the value of 4/3. I only want x values greater than that. So I'm going to have that part of the graph, and then I'm going to have this part of the graph, which is this equation for x values less than 4/3. So I'm going to get rid of the parts below, and voila, there's the graph. So this is how you sketch the graph of this absolute value function. So key things here really are, if you're going to do it this way, which I reckon is the easiest way of doing it, just make sure that when you've got stuff added after the absolute value function, that you only make the absolute value part the positive of that, and then as I did up here, and then the negative of that. And once you've found that x value, it's just the reverse of that for the second part of the absolute value function. So that's how you do this type of question, and I'll see you in the next one.